Okay, good afternoon, all of you. We'll see the same comparison of AC and DC transmission system. My screen is visible now. Hello.
Yes, sir.
It is very.
Yes, sir. It is moving.
Yeah. So there is a three things comparison majorly. One is economics, and then technical performance, then reliability. So these are the major comparison. We are comparing AC and DC transmission system with respect to these three terms. Economics we completed, and then technical performance also some of the subtopics we covered. Just I will recapitulate, and then rest of the parts of the parameter also I will explain. Then we'll move on to reliable operation, reliability. After that we'll see the what are the disadvantages of HVDC transmission, then advantages of HVDC, then applications, then comparison between AC and DC transmission with respect to all whatever we covered in this technical performance, all these things I will form as a table that is easy for you. If any short question or comparison, if they ask in general comparison, you can write that. Otherwise, if a question comes from this comparison of AC and DC transmission with respect to economic wise and then technical wise and reliability, all these things you can. And just review of previous class. There is a previously I covered some of the parameters in the technical wise, and I will just go through once and then we'll go to rest of the parameters. And as we aware that DC having some positive feature when compared to the AC, and because fast controllability and DC lines through converter control, because the controller is very fast, and there is some of the advantages. So these things are full control over power transmitted, ability to enhance the transmission transient and dynamic steady state and associated with AC network, fast control and limit fault current, and then feasibility to avoid the DC breakers in two terminal DC link. There is a when compared to AC breaker and the DC breakers also you can use it in the HVDC transmission. But once if you are using as a DC side, we must use DC links. And in addition to that previous thing, to overcome some of the problems in AC, you will see that some of the subtopics, there is a stability limit. This already we know that AC lines is dependent on the both sides of voltage angle as well as the reactant, that is V1 V2 by X into sine delta. So in that aspect we can able to control, and the angle increases with the distance. So here what will happen, if we are increasing the distance, angle also going to be increases, power transfer level. And maximum power transfer limit by the consideration of steady state and then transient stability, preferably will use up to the 90 degrees is the maximum. Power carrying capability of AC line is inversely proportional to the distance, but whereas in the DC line it remains constant. That also we observed on the graph what we discussed in the previous class also. Once if we are varying the distance, then AC stability limit will decreases, but whereas in the DC it remains in the constant. This what we discussed in the previously. Distance increases, then automatically relay power capability also decreases. That leads the less power transmission, whereas in the DC side it is going to be maintaining the constant. That is one of the thing we discussed. And then voltage limits. And there is a over voltage caused by the switching surges, all these things. Lightning must be limited to value, will not cause the puncture and flashover of the insulators and all. So AC line voltage control is a complex, Because line charging and inductive voltage drops will be takes place. Overhead lines, that is extra high voltage overhead lines, switching surges have comes more serious transient. That is the major problem in AC line. Then limit them in a peak value. It cannot be as a very high. You can able to limit that value to 2 to 3 times of the normal crest voltage. Crest is a peak voltage, that's nothing else, and you cannot increase beyond that. If it goes, automatically the insulator problems, all these things will arise. But whereas in DC transmission, switching surges are lower. It is only 1.5 times of that. And then voltage limits due to corona, maximum working voltage are in the minimum conductor size is limited on overhead lines. That is the another limitation in cables. Working voltage usually the limiting factor actually, whereas it cannot be very high voltages. But can current limit, you can see the temperature is the problem. You can maintain the temperature within the limits. That is also decided by the power transferring capability. If we are transmitting more power, automatically there is a temperature rise will increase, and also because of that losses is there, that will increase the temperature, that leads to sag in a lines. All these things will arise in the current, hence the current in the conductor must be limited. Cannot be very high currents during the ambient temperature. All these things we have to check it, and up to that level maximum capability they will specify in the each transmission line. In a system, power system, it consisting of a number of buses, number of generators, number of tap changing transformer, reactive power compensators, and then transmission lines. All these things are there, load, all together we call it as a power system. And when you are interlinking that transmission lines, you can see, suppose one of the line may be like this, and it is connected to something other transmission line. These are the some of the things, and here is another load, maybe something different. So these are the lines, so you can specify these lines. They will mention the limits, that is MVA limit will be specified. Up to that only you can transmit the power. If we try to beyond this, any one of the line is carrying obviously more current, then that leads as a overload. There may be outage. Once the line is outage, other lines will overload, consequently system will collapse. So all these problems will arise. You have to take care of that also. And then voltage control, you can see that long distance AC overhead lines and short distance AC cables, the generation and absorption of the reactive power by itself is a serious problem in AC. That's the, whereas in case of DC, you can see that what will happen, we don't require any reactive power compensation. But whereas in AC there is a reactive power compensation is taking place. Reactive power absorption and generation, all these things is a serious problem. You have to use the compensation time to time. The line produced the reactive power, this is all these things explained, just going fast little bit, we covered already. And this is a QC, and then reactive power line consumes the reactive power I square WC. Then if we equate these two things, we'll get it as a surge impedance. That will become as a Zn. We consider as a Zn as a nominal surge impedance loading. And these are the different resistances on the transmission line, bundle, conductor, array, cables, all these things is specified. And the thing is, power carrying by the line of the load, line loaded is Pn is V square by Zn, or you can say that the root of surge impedance loading. So that way also you can use. So SIL, that is a surge impedance loading. It depends only on the voltage and then impedance of the distance. And we can notice here P is equal to P and the voltages are same, and P is equal greater than Pn. Then you can see the different voltages are takes place are less than Cn also. Different voltages are there. All these things we have to use the compensation, whether you can see that natural load is greater than the normal load or less than the normal load. So all these things, it shows the diagram, the compensation is required until unless if P is equal to Pn. Other than that, we need as a compensation. So whether it is a system is absorbing the reactive power or system is generating the reactive power, all the means we must compensate these things. And if the same voltage is maintained at both end, equal amount of reactive power supplied at both ends, so that will not be the problem. But only the thing is, if the load on the line is less than, so load is a P and natural load is a Pn. If the load on the line is less than Pn, then net reactive power will produce by the line and is delivered to one or both ends. Now we can see the sentence P less than Pn, then what will happen? Reactive power is produced by the line, so it is generating. But whereas P greater than Pn, it is observed. So that is the phenomenon that depends on number of curves. You can see the less than Pn or greater than Pn and is equal to the Pn, that will be fine. And then the maintenance of constant voltage at the two ends required the reactive power, line loading is increased, and reactive power requirement increases with line length. And although you can see there is a DC converter station require the reactive power related to the power transmitted, the DC line itself does not require any reactive power. In DC side we don't require, but AC side is required. Steady state charging current in AC cables pose serious problems in making the break-even distance for cable transmission around 40 kilometers and all. And line compensation, this is also one of the important parameter. The compensation is essential. Whatever reasons we mentioned in the previously, there is AC line requires shunt and series compensation in a long distance transmission, mainly to overcome the problems of the charging and stability limitations. So we observed the stability limited distance with respect to the power transmission. If distance is increases, AC transmission line power carrying capability is going to be decreases, whereas in the DC constant line will be there. That means that power transferring capability will not affect on the distance in case of a DC transmission. So here you can see that the AC line requires shunt and series compensation in long distance transmission, mainly to overcome the problems of the charging and stability limitations. So these are the problem, but we have the lot of technology to compensate that. SVS, or nowadays there is SVC is there. SVS is nothing but a static wire system, and SVS controllers automatic, and another latest is developed, and the STATCOM also will be there. So all these things is make use to compensate as a reactive power. That's what the series capacitors, shunt inductors. So these are the purpose actually to compensate that power transfer and the voltage control also possible through use of STATCOM or a wire system or a SVC. So these things are suit to compensate that. And AC cable transmission, it is necessary to provide shunt compensation at the regular interval. So obviously, where is AC cables are there to maintain in the good conditions, so we need to provide the shunt compensation at the regular interval. That's what the AC cable diagram also we can see that every distance with shorter distance there is a regular interval we need to compensate that shunt compensation. And in case of DC line, such compensation is not required. Only the AC case it will be there, but in the DC case we don't require any compensation. And another problem is here, there is a problems of AC interconnection. If two systems are operating different frequencies or different voltages, that interconnection is a major problem. When two power systems are connected through AC tie line, right, between these two there is interconnection link. The automatic generation control of both systems have to coordinated using tie line power and frequency signal. When we want to tie line that the system, it must be take care of that. AC tie line is a lot of problems will be there. So the frequency signal also must be matched. And even with coordinated control of interconnected system, the operation of AC ties can be problem due to these are the reasons. So one is the presence of large power oscillations which lead to the frequency tripping. Once if it happens, that is nothing but a blackout. So we need to avoid that. To avoid, we just take care of these things. The presence of large power oscillations, then which is lead to the frequency tripping, increase in the fault level. So fault level also will increase, and then transmission of distribution from the one system to the other system. When we are doing this kind of activities, so means the increasing the fault level, because so some of the problems will be arise when you are interconnecting the AC system, two things. But now there is a controllability of power flow in a DC line, eliminate all the above problems. So that is the problems arise in a AC. Then what we'll do is to eliminate that. Obviously, once if you go with DC, that will be eliminated above the problem. In addition to the asynchronous DC ties, there is no need of coordination control. Whereas in the case of asynchronous in AC, there is a lot of things we need to take care. But here, direct way to synchronize that systems. In DC bus bar also we need to synchronize, because different sources of power will be available and we have to feed it in the grid. That's what there is a GPS synchronization also there nowadays. If you do the research or something, Google it related to the GPS synchronization also is available. It have to synchronize. Obviously, there is a different nominal frequency cannot be interconnected in AC ties actually. It requires as a DC link. Then only you can interconnect. That is the another problem is the ground impedance. This is also major thing in AC. There is AC transmission. The zero sequence current cannot be permitted in a steady state. But whereas due to this, what will happen? High magnitude of the grounding impedance, which is will not only the effect of power transfer, but also the result in the telephonic interference also the problem. That is the in AC case I am telling. Ground impedance is negligible for the DC current, and DC link can be operated using one conductor with a ground return. That will be in monopolar type. There is a three types of HVDC links, as I mentioned in the previous introduction also. There is a bipolar, monopolar, bipolar, homopolar. So these are the three. Next topic that only. So there is a three types of HVDC links. So monopolar, that will operate with only one conductor, and bipolar, two conductor will be there, and then homopolar. So depends on your requirement, you can choose. These are the thing. The ground return is objectional only when bidirectional metal structure are presented and then subjected to the corrosion with the DC current flow. So that when the DC current flows in the bidirectional structure, there is a ground return. Obviously, we have to use it. That is the reason monopolar case only one conductor is going to be used. While operating in monopolar mode, AC network feed the DC converter station operate with a balanced voltage and currents. And then ground impedance, you can see that single pole operation of a DC transmitter, whatever problems we noticed in the previously in the ground impedance, but what we are doing, single pole operation of a DC transmission system is possible for extended period, while in the AC transmission single phase operation is not possible for the more than a second. So if that problem will arise in the AC system, it cannot be operate more than 1 second, some seconds or otherwise. So whereas in the DC we can able to extend that period. That is all about the technical considerations. Whatever we discussed previously, technical performances, all these things will write. And then we'll move on to reliability. It is very blind way to explain in terms of HVDC transmission is going to be as a more reliable when compared to any of the system performance. And here the reliability aspect consideration of DC transmission is very simple. The equipment will not failure. So our wall will not failure. Our filters you can say that are different loads you can say. So our compensating component, all these things is a rarely will get the fault, but whereas another case of AC transmission that not that much reliable. And reliability of a transmission system, that is a DC side, good and compared to that of the AC system. The reliability of a DC links are very good. And then exhaustive record of existing DC link in the world is available, for which the reliability statistics can be computed. So I will show that statistics also. So what way in a DC transmission system is going to be as a more reliable. So that's what I mentioned in the upcoming slides. Remember that the performance of the thyristor wall in much more reliable than the mercury arc wall. As we know that in the olden days, before the advantage of power electronics, so what they will do is, power semiconductor devices, they use it as a mercury arc wall. That's the reason performance of this thyristor walls is much more reliable than the mercury arc wall. So that in the performance side, so DC transmission is a more reliable. And further development in devices, the development of direct light triggering. This is also one of the triggering method, as we discussed in power electronics also. There is a light triggering, thermal triggering, like that. So here with different scenario, even gate triggering, like that, you have many number of triggering circuits. Here there is a light triggering will be used more. So even I am explaining in the power electronics, at that time I mentioned you there is a light triggering, and light triggering, and that leads very less period of time it is going to be trigger the device. So that's the accuracy will be there, only that will be used in HVDC transmission. It won't be used in normal case. It is very accurate, and because here we are using as a 12 pulse converter and even 6 pulse converter also. You can see that the device conduction time taken to turn on the device and to break that junction J2, it will take very less time. And there is two measures of overall system reliability. So to say that system is more reliable or not, there is a two parameters we need to consider. One is energy availability, another one is a transient reliability. So to say the system is completely reliable, we need to check the two parameters. One is the energy availability and transient reliability. In a energy availability is defined as 100, there is a formula, nothing more, there is empirical formula. 100 is percentage, I am telling. 1 minus equivalent voltage limit to total time. So what is the equivalent outage time? Outage time in this meaning is nothing but a failure, or the device failure time, or any other component failure time. So like that they mention different devices in the how long it is going to be is working, that if anything is happened, how much time to repair, that also you have to consider in terms of the reliability aspect. That's what I wrote there. Outage time is the product of the actual outage time and the factor of system capacity lost due to the outage. So that is the formula. And then transient stability, this is a factor specifying the performance of HVDC systems during a recordable fault on a associated AC system. So they mention as a fault, once the fault is occurred in a substation or any other place, then what we have to do is there is a recordable fault on the system that we can able to find. There is a transient reliability aspect factor specifying the performance of HVDC system during recordable fault and associated AC system. Now there is the formula for transient reliability. Again, number of times HVDC system performed as designed by number of recordable AC faults. So now based on that we can easily identify which device is a faulty device. So that thing is mentioned here. These are the two formulas. Yeah, this is the recordable AC system faults are those faults which cause one or more AC bus phase voltage to drop below 90% of the voltage prior to the fault. So it is assumed that the short circuit level after the fault is not below the minimum specified converter operation. So there is another issue we need to highlight. Short circuit level after fault is we have to check it, should not be below the minimum specified operation, that is a converter operation. Both energy availability and transient of existing DC system with the thyristor wall is 95% or more. That shows as a more reliable. Either it is a energy availability formula you can use it, or transient of existing DC systems with thyristor wall is a 95% or a more. So if we are considering as a thyristor walls only, it's not required to discuss mercury arc wall even in the later units. So mercury arc walls are no more nowadays. So all the development semiconductor devices thyristor walls are using. The average failure rate of a thyristor in a wall is less than 0.6% per operating year. So that shows you can see another analysis, only 0.6 percentage of failure is taking place in a plant. It common practice to provide redundant thyristors in the series string count. That is also I shown you the diagram in the second introduction class. There is a what we have to do. Thyristor should be in the series string form only. It is not a one single thyristor. Even it is a 6 pulse or a 12 pulse converter, number of thyristors are maybe in general case you can say 6, but to increase the voltage level or a current level we need to use the thyristors are in series and parallel operation fashion, and will form as a one model, that is a HVDC wall. So that failed thyristors can be replaced during the scheduled maintenance period. So you cannot stop the plant and then you can repair it. There is a regular maintenance period is mentioned, one or twice in a year. During that instant you can one some cases one or thyristors, even cycler converter case also, very small one device is failure, it will not affect much, but very sensitive circuits it may happen. But in general case, especially in the DC transmission system, if any of so any of devices will not be affect much. You unmute ma. Yes for Teja. Yeah. Okay. It is that is what the maintenance once or twice a year we have to go for maintenance and you have to repair it. Maintenance of thyristor walls also much simpler than the mercury arc wall. When compared to the mercury arc wall, and thyristor replacement is easy. And then now I will show you there is a different time interval what will happen the in the case of reliability aspect, outage time, all this, that is a you can see that equipment, and then mean time to failure. Another one is a mean time to repair. So if any fault occur, how much time it will take to repair, that is also very important parameter. Suppose if fault occur and it may take more time to repair, then obviously reliability will be more. That is HVDC outage statistics I mentioned, thyristor group. You can see that mean time to failure, it is taking 13.7 years at the average. These are all available statistics in a book. And then to repair, you can see that only 6.1 hour. But similarly, converter transformer, obviously, failure will be very, very less. It is a big thing, because transformer, converter transformer, if it is a 12 pulse converter and all, star 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 delta, like that, we need to use that thing, but it will take repair time will be more. But smoothing reactor, you can see that it is never fail in general. You can see that 76.8 years failure will occur. So it is only during that long years, no component is there to fail in general. It is only the smooth reactor, and once it is fault occurred, to repair it will take much time, because all the design aspect and core saturation, all these things you have to take care and you have to design it. That is the smoothing reactor. And DC filter, and then AC filter. And DC filter 19.7, and then AC filter at 12.6, and then the master control, and then power control, pole control, pole of transmission line, and DC line switching. So all these problems arise in the particular time duration, MTTF, and then MTTR, mean time to repair. It will take only less time to repair, and that is the reason you can say that the reliability will be more. And in bipolar, you can back to back system, all these things they may use, the depends on the load condition, but anything, the failure percentage is very, very less. And you can see that there is a reliability of various alternatives. It must be kept in mind that bipolar DC line can be reliable as double AC line, even though if you are using as a two AC transmission lines are in parallel, if any one line fails, other line may be so, but still, when compared to the AC line, there is a same power capability. You can see that reliability will be more in a DC transmission. So this is because of the fact that failure of one people does not affect operation of the other people. So this is the because of fault on one pole does not affect operation of the other pole. This is a pole in the sense here is a positive pole and the negative pole things will be there. If the DC line conductor has adequate over voltage rating, and if the healthy pole, pre-fault power level can be maintained even with the permanent outage of the one pole. So if sometimes it may happen, the permanent outage also going to be takes place. So these are the major important question in this unit, comparison between the AC and DC transmission with respect to the all the three criteria. So each criteria elaborately you have to explain with logical points. Whatever I mentioned, many points I given, but if you are unable to remember that many, you just main points you can highlight in the exam. That is also fine. And you can see that disadvantages and advantages of a DC transmission, and then comparison of AC and DC transmission broadly. What based on that comparison is, whatever we discussed so far, all the three cases that will come into the comparison aspect. What are the disadvantages? Now you can see that first one, converter stations need to be connected to AC power grids are very expensive. So why that statement? You can see that whenever we want to transmit the power, that at moment you can see that cannot be utilized what you will do, you have to convert it into AC form. So you have to convert into AC and then synchronize to the grid. That will take expensive. Rectifier station and inverter stations are required. That is the one major problem. In contrast to AC system, designing and operation of multi-terminal HVDC systems also complex. That is what there in the fifth unit MTDC, that is a multi-terminal DC systems, that control also will be complicated. It is necessary to install expensive filter compensation units and reactive power compensation unit. This is also same as previously I quoted as a AC and DC filters are needed, as well as the compensation in the AC is required. That is the reason you can see that reactive power compensation unit, it is necessary to install expensive filter compensation unit in the reactive power. So reactive power compensation also needed because the source side is AC supply will be there. During short circuit in a AC power system close to connected to the DC substation, power fault also occur in a DC transmission system for a duration of a short circuit. If any short circuit occur in AC side, a DC system is followed by that, then once it is occur in a AC, obviously there is a fault will occur in a DC also. Another one is the grounding. HVDC transmission involves the complex and difficult installation. So grounding problem is a more in case of a DC transmission. So these are the disadvantages, and the flow of current through the earth is monopole. System can use the electro corrosion of the underground metal installation. So all these major 5 points are the disadvantages. And still you can see that another this is generally I told that long distance only 2 stations are sufficient, sending and receiving end. In between, suppose you want to operate or take tapping, again you from that point onwards you have to take it as a only 6 to 8 substations are installed. That too multi-terminal DC substations are installed. And then radio noise in the communication lines that situated near to the HVDC transmission. All these things are drawback. And another one is the inability to use the transformer. That already I mentioned in introduction class also. DC transmission side, we don't want to use any transformer because a transformer will operate in AC systems. That is the reason there with different voltage levels we can able to operate transformers. Because of that we can get it as a different voltage levels in AC, but in a DC straight away after transmission line you can use as a inverter station. That inverter station onwards it will convert DC to AC, and the AC form is going to be utilized in the different stage of when application side you can see that. And then difficult of breaking DC current, which results in high cost of a DC breaker. It is not a simple manner to break the circuit once it is in the operating condition. Like AC also there is a lot of difficulties, but still DC currents results in high cost of a circuit breakers. And you can see that another topic is advantages of a DC transmission. So far we observed disadvantages, and we'll move on to advantages of DC transmission. It require only 2 conductors. Anyhow, that is many times we discussed. One more is a written path. Otherwise, maximum 2. There is no problem of inductance, capacitance, and phase displacement, which is common in a AC transmission. So I explained in the case of compensation side, line compensation topic in a technical scenario. There we need as a capacitors and inductor to compensate in a AC transmission, but that problem will not arise in this AC DC case. And for the same load and sending end voltage, the voltage drop in a DC transmission line is less than the HS transmission line. So obviously a lot of things, corona losses, then there is some of the conductor losses, because it is only the two conductor or one conductor when compared to the AC. All these things, skin effect problem, that leads the DC voltage drop will be the less when compared to the AC. As there is no skin effect, that also I mentioned here, as there is no skin effect on a conductors, therefore entire cross section of the conductor is useful utilized, thereby affecting the saving of the material. Because of the corona in AC system, it is not utilizing properly, but now in the DC case you can utilize properly. And for the same value of voltage insulating materials, DC line experience less stress as compared to those of AC transmission line. DC line experience less stress when compared to the AC. So that is also one of the advantage. DC line has less corona loss and reduce the interference with the communication lines. So corona also will be less. There is no problem of system instability, so common in a AC transmission system. Whereas in the AC there is instability problems also there, but DC there is no problem of system instability. And you can see that in a comparison side, we'll all whatever we discussed so far, same thing it will repeat in terms of the point. There is HVDC as well as the HVAC. First thing is abbreviation I mentioned, high voltage DC or direct current and high voltage alternating current, like that. The type of transmission HVDC is a direct, that one is alternating type, and another one is a cost of transmission is low, that is only for after some distances. Cost of transmission is low in HVDC, whereas in high in HVAC, that is only the case of after break even distance. Before that directly cannot state that. The cost of equipment also will be high. So we can see that cost of equipment here is substations are there, rectifier and inverter station. The initial cost is going to be high. Obviously, other one will be low. And the transmission in HVDC are bidirectional is possible. You can send the power or you can receive the power directly through what you call it as send and receiving powers, or HVDC case is a bidirectional, but whereas in AC case is a unidirectional. Again I mentioned corona will be less in HVDC compared to the AC, there will be more. So there is possibility of asynchronous interconnection of a HVDC system, but whereas there it is not possible. So there is a asynchronous interconnection, high voltage alternating current is required, that we can consideration. And then another skin effect is very less, and whereas in AC case skin effect is more. The voltage regulation and the controllability is better in HVDC, whereas low in HVAC. There is need of insulation in HVDC care are less, so HVDC insulations are less, but whereas in AC side lot of insulations need to installed in a overhead lines. You can see that each line we are connecting as a insulator when erection of the towers, all these things. And line cost is low in HVDC, high in AC. The cost of towers is not expensive and the size of towers are not big in HVDC compared to the HVAC transmission. So this is the cost of towers is not expensive. in case of a DC, but obviously in case of AC it is expensive. And you'll see the applications, majorly 4 applications. Then I have to elaborate that each and every one that will come across the application. Anyhow, that we'll see a little bit broad explanation. There is a long distance bulk power transmission, underground or underwater cables, then asynchronous interconnection of AC systems operating at different frequencies, or whereas the independent controller of a system. So these are the some of the major application, and then we'll see that each one. So what is long distance bulk power in the what is the scenario, and underground cable what is scenario, and asynchronous interconnection. What is the previous scenario of HVDC? Then what is the latest trend? Then how to use the modern techniques. So all these things we'll discuss it in next class. If any doubt you can ask me. Otherwise you can post the attendance and then leave. Anyhow, maybe in the next week onwards, what you call it as offline, I think so. Maybe we'll see that.
Excuse me, sir.
Yeah, tell me.
Sir, this is roll number 105. There seems to be some glitch in my laptop. I'm unable to give my attendance via chat box. So I just
No. Chat box is not mandatory. It is only for cross-checking purpose. But I will get the attendance in the download sheet. Once if you join, and that will record you automatically. At what time you joined and what time you left, everything it will be recorded. No issue in that.
Yes, sir. Sir, for this sake, I've been exiting and joining multiple times in the end, so I thought I would just let you know.
Yeah, that also will show. No issue in that.
Yes, sir. Thank you.
Okay.